going to start some.
Like what?
Like 45.
9:45.
10:45.
Okay, I'll be back.
Yeah. Okay. So okay. Besides that, any more questions? No. Okay. So now let's look at the review. You would like to give an example. What would be a one-to-one function? What would be a composite function? Like what is f, what is g, and what is f composed with g?
Is that like literal translations or examples that we need?
You mean for example or for definition?
Do we need the definition? Like
You do need to.
And the example, or just
Yeah,
the example?
both. You need both.
For both.
Yeah.
For a composite function and one-to-one.
Exactly.
The word definition and the example.
Yes. Yes. Okay. So for example, we can start with this. Can you give me one example for this? What would be the f you would like to define, for example? Give me one definition for f. What is the f you would like to give me, for example? Like what?
I didn't understand it, that's why.
Okay, all right. So now you know, right? So just give me one example so we can get some practice. One is a constant. That's very boring, right? Let's give something involved with x. X minus 7. Okay, x minus 7. All right. Now, can you give another example for g? Well, let's use like a quadratic or reciprocal or cubic function, whatever. Square root of 5. Okay, I like that one. Square root of involved with x. How about this? Involved with x, because if you don't have x, then it's a constant. X
Plus 5.
inside?
Yeah, inside.
Okay.
Everything underneath.
Okay, that's good. All right. So now you can say, for example, if f is this and g is that, then what is the definition of f composed with g? Then you would say, well, f composed with g is f of g. And now you can tell people what is that. Now you can tell me, what is that? Everybody look at this. Can you see? Now you have side by side. Can you tell me what is f of g of x? It is what? What do you start with? You start with g or you start with f? G. You start with the inner function. So what about f? You don't do it. You have to have f stand by. So you what? Copy down. Thank you. Okay, so you would have f of, now what is g of x? It is, very good. It is just square root of x plus 5, right? Is that okay? You only do g of x, right? F cannot do. So f, you just move it down, just copy down. Now, what is the input for f? What is the input for f? It's the whole thing here, that's square root of x plus 5. So you are going to substitute this into the definition of f. What is f? F is x minus 7. So when you see x, you will substitute by this. Is that right? So anyone would like to tell me what would you have? You will be square root of x plus 5. Okay? And then, after that, you will have minus 7. Is that okay? Oh, I'm so sorry. Okay? So now this is your definition. F composed with g of x. Is that okay? Yes. Okay. Yeah.
So you need the word definition and an example.
And then, right. I need this. Okay, what about this? This is the expression. Okay, on the book, you just say, let f be a function and g is a function, right? And the composition of f composed with g is defined by this. Just a few words. Okay? Can I guide you look at your book? Can I have all of you look at your book? Okay? On the book, what it says? Open your book. Open your book. Which page? Where's the book? Where do we learn the composition? We learn composition. Yeah, when we learn the inverse functions and so forth. That's 8.1, right? Beginning of the chapter 8. Okay, so let's see who can find it. Okay, which page? 628, here. Okay? So actually, the wording part, just say what? All right, you are given two functions. One is f and one is g, right? And we say in words, f composed with g, right? F composed with g. Is that right? It's defined as following. Is that okay?
I'm sorry, defined as what?
Okay. Can I have all of you read out loud the whole definition one time? Okay, 1, 2, 3.
Given two functions f and g, the composite function denoted by f composed with g, read as f of g, is defined by f composed with g of x equals f of g of x.
We have read this several times, right, when we started. So the wording part, it's actually just let you know that, yes, you are given two functions, right? One is f and one is g. Now we are going to define the composite function f composed with g.
So
What is that? And that is how we define.
that's the
And
definition right there?
yes, that is the definition. In math symbol, it's just this.
And we have to write it in English.
Yes.
So we'll just write
It
f
just
composed with g of x equals f of g of x.
So what are you going to do is, okay, so let me make it complete. I wrote the most important part. Given two functions, f and g, the composite function, okay, is f composite with g, right? Is defined by the following expression. Is that okay?
So that's what we have to write.
Yes, right? But what is the most important part? Is this, right? Is it clear now? We have to be trained so that you can communicate with people, talk about math, think about math, okay? Express using the proper mathematical language. So there are two functions we're given. One is f, one is g. The composite function, we denote it by f, circle g, but we read f composite with g that way. Okay? Is that okay? Okay, let's read one more time. Given two functions, f and g, the composite function f composed with g, we read f composite, oh, there's f composited with g. Okay, it's defined by this. Okay. Next, what about one-to-one function? Definition of a one-to-one function is what? It's a function such that two different inputs correspond to what? Two different outputs, right? Now you can give a definition. So you can say, for example, can you give me one example? Who would like to give me a very simple example? How about this one? X minus 7. Is that a one-to-one function? Yes, because what? The graph is a line, and that is increasing, right? All the increasing function, all the decreasing function pass the horizontal line test, right? So if you want to give me a more interesting one, you may. You can have cubic function. How about quadratic? Is quadratic? No. Is quadratic one-to-one? No, because what? Look at this parabola. It doesn't pass the horizontal line test, right? Okay, so any one of you would like to give me anything which has a shape of line, it will be fine. Or, you can say or what? Somebody give me one?
Or f of x equals 2x plus 1.
Okay, that's just a line. Can you give me something not linear? Okay, x cubed. Thank you. Is x cubed one-to-one?
Yes.
Yes. The shape of one-to-one, the shape of x cubed, human body, language, body language. What is the shape of x cubed? Like this, right? Okay. Is that right? It's an increasing function, so does it pass the horizontal line test? Yes. What else? What else you can give as an example for one-to-one function? Or what? Square root? Are you sure? Is square root one-to-one? No. Okay. Oh, I mean, I'm so sorry. Square root is one-to-one. I'm talking about, yes. Square root. Because square root is also what? Increasing, right? Is this one-to-one? Yes. It passed the horizontal line test. Okay. Does it make sense now? Now let's look at number 3. We went over that yesterday. Is it clear now? When we add, subtract, multiply, or divide two functions, the domain will be the common part, right? F has to be defined and G has to be defined so that I can look at both and talk about how to add them, subtract them, or multiply them, or divide them. Is that right? So the domain will be their intersection.
That's all we would write.
Exactly.
Nothing more.
Nothing more. Okay. You mean here? Yes. That's all you write. The domain of this new function, f plus g, is the domain of f intersects the domain of g. Right? The common part. Remember, we talked about this. For example, this is my f of x, radical x. Now, this is my g of x, which is a line. Let me say this is negative 4/3 x plus 5. Sorry?
All of that? You putting it here?
No, I just give one example. Okay. So this is f, that is g. If I want to add them, where I can add them? I have to be able to talk about both of them to be able to add them, right? So can I add f and g here? No, because what? Here, there's no f. Where you have both f and g, it has to be starting from 0 and greater than 0, right? Only those points you can talk about both and you can add them. Are you with me? Is that okay?
No, not really.
Okay. I want to add f and g. Okay, I probably should write here. F plus g of x is defined by f of x plus g of x. Okay? So I have to be able to talk about f of x, and I have to be able to talk about g of x, right? So where I can talk about f of x, I can only talk about f of x when it is 0 or greater than 0. Less than 0, I cannot have f at all, right? So I can talk about g everywhere because this is defined on all the real numbers. So if I want to talk about both, x has to be on just from 0 to infinity, which is the common part of their domains, the intersection of both domains. Is that okay? Okay. All right. Now let's look at the composition. Well, this is just talk about the definition. And about its domain, I'm not going to test you this time for the domain. Don't worry about that, okay? We will talk about that later. Okay, we went over this yesterday about how you find the compositions of two functions. We talk about zeros. That means you find where it will equal to 0, right? Remember that? Okay? All right, now let's practice on this logarithm. I think this is the part you need a lot of practice. Am I correct? Okay, so now let's do it. Okay, great. All right, change the logarithmic statement to the equivalent exponential statement. Let me ask you, for this notation, what is the base? 2. 2 is the base. 2 is the base. 2 is the base. So it means what? 2 to the power negative 6 is 1 over 64. The output of log gives us exponent. So the exponential expression is very good. So write it down. You say 2 to the power, what? Negative 6 equals to 1 over 64. Thank you. Wonderful. Okay? So remember, when you want to change from logarithmic statement to exponential statement, the first thing you want to identify is the base. Which part is the base? It's not that hard to identify, right? So 2 is the base. Am I correct? The output for log gives us the exponent. Does it make sense? Okay. All right, let's look at the next. 5 cubed equals 125. And they want us to write it in logarithmic statement. What is the base? 5 is the base. Okay? All right, so you would like to write it, right. You would like to write it so that the base here is 5. Okay? All right, and then the exponent is going to be the output. So the exponent is 3. Okay, the argument for the log is 125. The base is 5. Log to the base 5 of 125 is 3. Does it make sense now? Yes. Okay, so one more time. When you want to write exponential statement to logarithmic statement, you identify the base. The base is 5. Okay? So log to the base 5. Log to the base 5. And always remember, after you use the log, you are going to produce the exponent. So the output is exponent. Okay? So log to the base 5 of 125 equals to 3. You should be able to write from exponential to logarithmic statement and also from logarithmic statement to exponential statement. Okay? All right. Now let's do some evaluation. Yes.
If you do part B, so let's say they so has the square root, like the square root of 3 power.
Here. Okay, sure. Look at this one. You would like to find what is that, right? This is a question. You would like to find what is that. So you say, I don't know what is this. I don't know what is this. So let me let this equals to something, a variable. So I let this to be equal to x. Does it make sense? Yeah? Because we are familiar with exponential expression. We feel more comfortable with exponential. So we usually like to write the logarithmic expression as exponential. Okay? So log to the base square root of 3 equal to x means what? The base is what? What is the base? Square root of 3. So square root of 3 to what power? So it's x equal to 3. That is the question. Am I correct? All right?
So since there's no y to the x there, since there's no
We want to find the value of this, right? So I don't know what is this value. So I say this equal to something I don't know, right? And I write that statement as exponential. So now this becomes square root of 3 to the power x equals to 3. Well, square root of 3 to what power equals to 3? Square root of 3 times square root of 3 equal to 3. So the power here should be 2. Is that okay? No. Okay. Let me add yes. Small number like what? You want larger number?
We make the base equal 3.
The base? What is the base? The base is square root of 3.
So that small square root symbol that we just write like that.
It will be what?
The square root of 3. We leave it small like that as the base.
Yeah, square root of 3 is the base. Square root of 3 is the base. Let me give you more examples, okay? Okay, more examples. Let's see. I think that it's because most of you not familiar with the logarithmic function, so you kind of feel a little bit scared. What would be the good example? Can I give you something not square root? Give me a number that you feel not scared. Oh, we have done 2 for a long time. Can we? 5? 9. Sorry?
What about square root of 5?
Oh, square root of 5? Oh, you like square root of 5. Fine. Square root of 5. Now, I'm going to change this to be 25. Okay? And now I would like to find out what is that. Okay? what would you do? Okay, now
So you mean, you do the square root of 9 and then,
a square root of 5. Now it's the square root of 5, not 9.
so would it be 9 and then the exponent 81?
Hold on.
Is that right?
We are talking about square root of 5 or square root of 9?
I was just using that example.
Oh. If we look at this problem, the base is what? Square root of 5, right?
It is.
Okay. And we try to find out if the base is square root of 5, what will be the power so that I will get 25? Does it make sense? Okay, look at this. The base is square root of 5. The power, the exponent is x. Okay, so it means square root of 5 to the power x equals to 25. Is that okay? If you don't feel comfortable with square root of 5, can anyone tell me square root of 5 is 5 to what power? I help you to recall what you have learned before. Square root of 5 is 5 to what power? Thank you. Who said 1/2? Extra points. Good. Do you recall? No. Not at all. Okay. So let me tell you. Square root of 5 times square root of 5 is what? Is 5. Yes? Square root of 5 is 5 to the 1/2 power. Square root of 5 is 5 to the 1/2 power. So remember, when you multiply, you add up the exponent. So yes, you do get 5 to the power 1. That is 5, right? This is something that you have learned before. Maybe you didn't learn that deep, so you're not quite familiar with what you have learned. But we will relearn all of those again, okay? But I just try to help you that retain what you have learned. And you can apply to this problem, and let me show you. If radical 5 is 5 to the power 1/2, then we are going to have is 5 to the power 1/2. Does it make sense to you guys? What is the square root of 5? Square root of 5 is 5 to the power 1/2. And when we have power of power, we multiply the exponent. Is that okay? What is 25? Can anybody tell me what is 25? 25 is 5 to what power? 5 to the power 2. Okay? So now let's see. Sorry. When I multiply 1/2 with x, what do I have? It's what? Isn't that 1 over 2 times x, right? Which is x over 2. Am I correct? Yes or no? Yes. Okay. So look at the power. On the left side is x over 2. On the right side is 2. They should be equal because they have the same base. Are you with me? Therefore, you say here. So that you say, well, because exponential is 1 to 1, so x over 2 equals to what? To 2. If x over 2 equals to 2, what is x? X equals to 4. Yes. Is that okay? This is a more involved one that you ask, okay? But it is okay. What I try to show you is a little bit different from there. Okay, this is, I mean, they are the same actually, because over there is 3 to the power 1, okay? And 1/2 of x equal to 1, so x equal to 2. Here, this is 5 to the power 2. This is 5 to the power 1/2, and then to the power x. So look at the exponent is multiplying 1/2 with x. So you have x over 2 as the exponent. Here you have 2. They should be equal because they have the same base. What happened to the base? No, it's just like this. We have the same base, and I say when I multiply twice, it's the same. This guy also have the same base as that guy that to the power, multiply so many times. So since we have the same base to multiply, so we just need to compare the exponent. Okay, let me draw this. Exponent function. Exponent function like this, right? It is 1 to 1. Is that right? It is 1 to 1. So different input, if this one is different from that one, they will have different output, right? We all know that. So if they have the same output, if you have different input, you will have different output. So if the output are the same, means what? Input must be the same. Does it make sense? One more time. Different input will give you different output. If you find out that output are the same, what do you say? You say input must be the same. For example, different people would have different social security number, right? And now you have, look at two output and then check their social security. You say, hey, these two output, they have the same social security number. It means what? Those two documents must from the same person, right? Different people would have different social. So if the social security number are the same, means what? It must be from the same person. This is the output from the base 5 exponential function. They have the same output, right? 5 to this power equal to 5 to the power 2. So that means what? The power must be the same. Otherwise, they will not have the same output. Okay? Yes?
How do you know when to use the 1/2?
Oh, because it's a square root. If it's cube root, it will be 1 cube, 1 over 3. Sorry? You mean? Oh. Oh, I can use it there. Let me show you. Yeah, because it's square root, so we did not, we feel it is very straightforward, so we didn't do that, but we can definitely do that. Okay, so it's like this. What is 3? 3 is 3 to what power? Can you tell me? Power 1, right? Can you see? This is the previous problem. Okay? We have up to here, right? The base is square root of 3 to the power x equal to 3. All right, now let me write square root of 3 as 3 to half power, and then to the power of x. So this is 3 to the power 1/2 times x. Does it make sense to you guys? Okay? It's exactly the same as what we did there. let me do it one more time. Give you one more step like that. Okay? Yes.
Is there the best complicated way to solve that? Because it's like really confusing.
Okay. The confusing part here is just because you did not quite familiar or remember this. Okay. And yes, the radical base, if I give you radical number as a base, most of you feel like you're like so afraid because you are not familiar with the rational exponent. This time, you will not have radical number as the base. So we will have that for the future, for the next unit, unit 2. So you will,
There's no radical base.
yeah. So does it make you feel more comfortable? Yeah. I'm assessing. You have to know what we are doing right now. We are making new friends with exponential functions and logarithmic functions, okay? They are new to most of you, okay, if not all of you. And I want you to feel at least you know the relationship between exponential and logarithm. What is the relationship between them? They are inverses of each other, right? Yes? That is the most important thing you have to know. Okay. Is that okay so far? Yes. Not very loud. Okay. All right. Now, let's see. Is the D part okay? I know this is not easy. I truly feel that. So, you know, I know what's going on, and I know this you have tried. And this is not stopping here, okay? Actually, after the exam, you are continuing learning exponential and logarithmic things because that's how this approach helps students. You have to be able to see every function at one time for one unit. And then next unit, you are going to see all the expressions for all types. So you are going to see linear, quadratic, radical, and then cubic, and then polynomial, exponential, and logarithmic expressions, and you will be able to simplify them. The next unit, you are going to see equations. You're going to have linear, quadratic, cubic, polynomial, radical, exponential, and logarithmic equations. So you're going to see every type for every unit so that you will not feel scared when you have your final exam. Does it make sense to you guys? So when is the hardest unit? The unit 1. It's the one unit that you are going to prepare for your test because you are knowing new friends. So like when you walk into a conference, right? A workshop, you know so many friends. On day 1, you can hardly tell their names, right? What about day 2? You get to know a little bit more for each one. Day 3, after a week, you know everyone very well. So everybody you will know a little bit. They're looking, you know. And then the second day, you have some conversation and so forth, just like this. So unit 1, yes, it is not easy. And I already told you, I will test you focusing on what? Composition function, inverse function finding, domain and range, right? And also very simple with the integer base, okay? Or the fraction base. We could make it hard, but I will not make it hard, okay? All right, now let's see. What else? Which one? D? D part. Did you know how to do, wait a second. D part, remember the composition of function f and f inverse. Okay. F composed with f of x, f composed with f inverse. How do we understand that? Last week, we use the analogy of taking train from Los Angeles to San Diego, and then you will take the inverse train from San Diego to where? To Los Angeles. So remember, if this f, let me say what is f? F is x plus 7. That's Alberto's example, right? So Alberto say, if you get on my train, everybody is going to have 7 more. Okay, so if you have 5, then you will map to what? 12, right? Now take this inverse train. So now there's another inverse train. Who would like to be that inverse train? Oh, okay. So the inverse means what? You will reverse the operation. So what is the work? What is the task? If somebody sit on your train, what would they do? They will what? Take away 7. It's reverse whatever that have been done. So f inverse, remember, it will be what? X minus 7. So coming back with the inverse function f inverse, is going back to 5 because from 12 to 5, it's just minus 7. You say, Dr. Chen, I don't believe you. Why you say this is x minus 7? Do you know why it is x minus 7? You can show it, right? Okay, give you this. How do you find that? How do you find the f inverse of x plus 7? Step 1. What is the step 1? You let what? Y equal to x plus 7. What is the step 2? Interchange x and y. So this become x and x become y. Is that right? What is the step 3? You solve for y. So y equal to x minus 7. What is the step 4? Conclusion. So you say f inverse of x is what? X minus 7. Bingo. Right? So the inverse function is to reverse what you have done in the function. Does it make sense? So if your function is to add 7, your inverse is to what? Subtract 7. So if you start with 5, with the function, okay, with the train, Alberto train, it's going to arrive at 12, right? And remind us your name. Nicole, with the inverse train, then Nicole is going to take away 7, so go back to 5, right? So what did we conclude? We say if 2 functions are inverses of each other, okay, you take f of x first, and then you take f inverse. What is that? F inverse of f, it is what? Composition. Am I correct? Is that right? Okay. F inverse composed of f, it is this, right? Which is what? X, right? And then the second one is if you take f inverse first and then take f, you will also get x. So if you go with the f inverse, so like Nicole say, I would start with 12. I would go with f inverse first. Okay, let me write this completely. Okay, if Nicole start with 12, take the inverse. So Nicole will take away 7. Take away 7. And then take Alberto train. It will add 7, so we'll come back to 12. Right? Start with 12, come in here with 5, and then end with 12. Does it make sense? Yes.
So you know how like the problems in the back, it's like something that equals to x?
You are
Yes.
awesome. You are awesome. We will do that. You are awesome. Yeah. Okay. You mean say what again? What he just said. Okay, what he just said. Okay, I will finish this and I will jump to what he said. Okay. All right. So let's look at this part D. Okay, let's look at this part D. What is part D? This says 7 to the power log with the base 7 to the base 7 of 49. All right. So what do you see? Aha. This is base what? Everybody with me? This is a base 7. Okay, can you tell me What about the exponent? It's log to the base 7 of 49, right? So, so what do you do first? You do the exponent first, remember? Okay, so what is the exponent? The exponent is what? It's a log. Yeah, it is 2. All right, so the exponent is 2. Did you see that 2? Log to the base 7 of 49 is what? 2. Because 7 to the power 2 is 49. Do you see that? Yes? You need, yes or no?
So you change it from log 7 to 7 squared?
You change, okay, where did I write? Okay, right here. Okay, log to the base 7, 49. What is that? You're asking yourself, what is the power? So that 7 to that power is 49. Remember? 7 to what power equal to 49? 2. Okay, let's practice more. Log to the base 10 of 1,000 means what? Find the power. 10 to that power equal to 1,000, which is 3. Log to the base 3, 81. 3 to what power give you 81? 4. Yes? Log to the base 1/2, 8. 1/2 to what power give you 8? If you say 3, it will be 1/8, right? You need to take reciprocal. Okay, one more time. If you say 3, you get 1/8, right? But you get 8, so you need to take what? Reciprocal, so it should be -3. Because when you take the negative, it means what? Taking reciprocal, right? 1/2, the reciprocal 1/2 is what? 2. 2 cubed is 8. All right. Anybody want to give me one base? No radical, right? I know. Okay, what do you like? 1/3? Okay. All right. 1/3. And what do you want? How about 9? What is log to the base 1/3 of 9? It will be -2. Does it make sense? Yes? Okay. So far, so good? All right. So now it's no problem. The log to the base 7 of 49 is 2. Am I correct? Yes or no? All right. Remember, this is 2. Now, 7 to the power 2 is what? 49. Okay? You may. And I'm going to have you, don't write on the paper yet. Okay? Just look at it. See what you've done. You have done log, and then you do exponential. Look, they both have the same base, right? This is the log with the base 7. This is exponential with the base 7. So you are doing log train, and then you take the exponential train. So what does it tell you? You go back to wherever you start. Am I correct? One more time, because log and exponential are inverses, right? If they have the same base. So you take the log train, and then you take the exponential train with the same base. You should go back to wherever you start. Yes, you start with 49, so you end with 49. So you don't need to compute. You still get 49. The answer is 49. If you look at what? If you look at this, okay? Composition of inverses will get identity. Does it make sense? Okay? So that's why you look at this one. It's x to the power log to the base x, 23. You take log with what base? X. Now you take the exponential with what base? X. Do they have the same base? Yes. So what? They are inverses, right? Do you need to compute? No. What is the property that we use? Remember this train, okay? Inverse train from Los Angeles to San Diego, or go to what? Legoland. Okay, so you don't need to compute. You just need to say it's inverses of each other, so it's identity. You would just get 23. Does it make sense? Okay? Isn't that fun? Okay, you want me to tell you why, so I'm telling you what has been done. Okay, this is about domain and range. We have talked about that.
Can you go over to 9C? Is it bracket 0, comma, infinity, open parentheses? Number 9, part C, for the range.
Wait. Sorry. What do you say?
Part C, the range, is it bracket 0, comma, infinity, parentheses?
Oh, you mean you're talking about the range for part C?
Yeah.
Yeah, the part C range is what? It's positive or 0. Okay, it's greater than or equal to 0. It's the same. It's the same as the part B. Yes.
Thank you.
Okay, because it is a shifting to the left. Okay, this is y equal to radical x, and you shift to the left. How many units? 3 units, and you get that. This is y equal to square root x plus 3.
Why did you put a bracket? See part C at the end, you put open parentheses, negative 3, comma, infinity bracket?
Here?
No, right underneath it. The next one. Go down that one.
Here?
Why did you put a bracket for infinity?
Oh, I'm so sorry. It shouldn't be I'm so sorry. It's not right. It should be different. I think there was a typo. It would be like this. It's obviously a typo. Yeah. Okay? It is greater than or equal to negative 3. So with the brackets and negative 3, right? Including negative 3 to infinity. Thank you for catching that. Does it make sense now?
Yes.
Now,
That E, that sideways E means X is
belongs to, is an element of.
X is an element of the real
X is an element of the set of real number. This is the set of all real number. So how do you read that? Okay, you want me to write it down? No problem. Okay. No, I'm very happy to write this down. You read X is an element of the set of all real numbers. Okay, this is how you read it. We read X, just for that symbol. Oops, excuse me. Okay? Is that okay? Yes. For this part. Okay, now, come back to the question at the end. You have all these. I'm going to make a PDF so that all of you will not have those kind of funny symbol. Okay, for example, number 10. You will answer whether a function is 1-to-1. Is this 1-to-1? Yes, because what? It is cubic function. It passed a horizontal line test. Okay, what is the domain? It will be the set of all real numbers, or you can say just that big R, right? With the double bar, usually. Okay? And find the inverse. So first you will let what? Y equal to the function. Okay? That is a step 1. And then step 2, you will interchange x and y. So interchange them. Step 3, you will solve for y. You solve it. And then at the end, you will have conclusion. Did you get that? Mm-hmm. Yes or no? Okay? Now, next one. Is this quadratic function look familiar to all of you? It is facing up or facing down? Up. Okay. And so if you start with the function x squared, you will shift to where? Right. How many units? 1. And then you shift up. How many units? 3 units. And where is the vertex? 1, 3. I'm so happy. Okay. And the parabola is facing upward. Okay, find the axis of symmetry. So where is the axis of symmetry? It's a vertical line passing through the vertex. So it's what? X equals to 1. Because when x equals to 1, right? Is that right? Who does not understand this? Any? It's okay. All right.
So first one is all the numbers in
What?
you said for A.
The answer for A is 1, 3. Okay? Because when x equal to 1, it is a minimum. Okay? Because that is 0. And you only have value 3. Okay. It's open upward. Okay? Now, find the axis of symmetry, and we know the answer should be x equals to 1, right? The equation for the axis of symmetry is x equals to 1. You have, if anyone, and I know I'm going to see some of you write this, just number 1. If you only write number 1, do you know how many points you will get? 0. Yes. Thank you. No half. You must write an equation, okay? If you only give me number 1, sorry, it's wrong. Okay? And again, I encourage all of you work in groups. Is this function one-to-one?
No, because
Somebody say yes? Who say yes? Oh, this is a parabola. Smiling face. Oh, I'm going to cry. I mean, parabola is what? Does it pass the horizontal line test? No, so it is not one-to-one. Okay, now find the domain. What is the domain?
-3,
Thank you. So it will be all the set of all real numbers, right? Negative infinity to infinity. Does it make sense to all of you? Okay. All right, find the inverse if it exists. And what do you say?
No.
You say, I don't need to find it. I get the points. Since it is not 1 to 1, it does not have its inverse function. You know what do we do with this case? And later on you are going to see, because this is a parabola, right? And where's the domain? It's all real number, right? In order for us to find or talk about its one-to-one, its inverse, we say, you know what? I'm going to restrict your domain. Say, cut off this part. The domain now is from 0 to infinity. Then, is it one-to-one now? If you only talk about the domain from 0 to infinity, it will become one-to-one. Then we can talk about its inverse, okay? We don't talk about it right now. If you only talk about the whole domain, if the domain is the whole real number, it is not one-to-one. Is that clear? Okay. All right. This is something that you have done and you know it so well. Okay, I'm going to test you about the logarithm. So yes, you are going to draw something like this, like 2 to the power x. Now, you know what? I am going to change this like this. Can you draw this, my friend? Yes or no? You say yes. Dr. Chen, this is piece of cake. Chocolate cake. Okay, you want to draw this. So what is the step 1? You say, well, it will be just graph y equal to 2 to the power x. I'm very happy. And you get this, right? Passing 1, y 2 to the x. All right? Okay, but what do you want? You want x minus 1. This minus 1 is with y or with x? With x, right? So it has impact with x. So in order for us to get the same y value, the new x has to be what? 1 more. So it's shifting to where? To the right. You shift it to the right 1 unit to get y equal to 2 to the power x minus 1. So how do you draw? You would just say, hey, this point will become here. And this point, every point is going to shift 1, okay? And you will have something like this. So this was 1/2, now become here. So this is y equal to 2 to the power x minus 1. Is that okay? If I have, this is example 1. If I say draw y equal to 2 to the power x minus 1 plus 3, then what do? You say, well, I already get 2 to the power x minus 1. How about this plus 3? This plus 3 is, who is plusing 3? Y. The result y is plus. So you are going to what? Shift up. Are you with me? Yeah. In other words, if I have this plus 3 after this, you will have step 3, which is shift it up 3 units. Is that okay? Then you shift it up. So now this will become 2, 3, will become here. And you are going to see this is y equal to 0. Now you will have y equals to 3 as your asymptote. The whole function is going to get closer and closer to this horizontal line. You see what I'm saying? This is y equal to 2 to the power x minus 1, and then plus 3. Yes?
So for the inverse of that graph, we just switch the points we got, right?
Oh, how do we find the inverse of that graph? You asked us such a wonderful question. You know my mind, huh? You can read my mind. Find f inverse. So f is 2 to the power x minus 1 plus 3. Now be creative, okay? You know how to do this. What is the step 1? Let what? Y equal to 2 to the power x minus 1 plus 3. Are you with me? Yes or no? Yes. How about the step 2? You will interchange what? X and y. Yes? How about step 3? You solve for y. So how do you solve for y? Subtract 3 on both sides. You have 2 to the power y minus 1, right? And then, how do I solve for y? So let me solve for this. I need to take log on both sides. So remember, how do you write this in logarithmic form? What is the base? Tell me. What is the base? Base what? Base 2. So you can write what? Log with the base 2, x minus 3 give you y minus 1, right? Because the output for log is the exponent. You see that? You just write the exponential form in log form. Am I correct? Okay? All right. Now, what is y? You add what? 1 on both sides. So what is y? Y is log 2 x minus 3 plus 1. Okay? So what is the step 4? Conclusion, right? So the F inverse is log 2 x minus 3 plus 1. Bingo. Okay? Just one. It will be similar to this problem. Okay? So you will have F inverse. Okay, so now I'm telling you one problem that I'm going to test you. Okay? The only thing you need to know is how you write the exponential to log. How you write log to exponential. Does it make sense to you guys? Okay, so let's come back. Rewind. Let's rewind our tape. Come up to here. It's just as before, right? How can I solve for y? How can I solve for y? Oh, it's in the exponent. Hey, my good friend is in the exponent. How can I get exponent? Through log. So I write this exponential expression into log expression. So how do we do that? You identify what is the base. What is the base? 2. 2 is the base. If 2 is the base, then everything will become so clear. So sorry. Okay? Oh, that didn't do it. Yes?
Then how do you graph the log 2x?
How do I graph the log 2?
Right here, like you have this question right here. You have
Oh,
g of x.
how do you graph log to the base 2 of x? Okay, remember, it will pass this point, 1, 0. Okay, and then 2 is 1. So this is the log x. Does it make sense? This is your log to the base 2x. So how do you graph this? You graph this and then shift to the right. How many units? 3 units. And then you shift what? Up. How many units? 1 unit. Okay? This will be one problem tomorrow. Okay? 1. I hope this is a good review for all of you. Is it helpful to all of you? Do you want me to put this on the canvas for all of you? And tomorrow I will have a request that you need to turn in this whole packet on paper, okay? So besides those, all the homework that you should turn in, you will have this packet. You just handwrite to it, to that top page, okay? I want you to turn in this review packet, the packet for review. Okay, thank you very much. And I hope you have a good review.